In this video, we're going to talk about the solution of 14 sinusoidal functions. Okay, so given a function, now you are given a function t equal to a sine of b of t minus c, close parenthesis, plus d, right? So remember, we mentioned about a, b, c, d are just numbers. We're going to figure this out. So when we say when there is a picture, the answer is in the picture, easy. But if we don't see the picture yet, we got to process the reading to get all those information. So let's go. Blah, blah, blah. You see the highest one, it gives you the maximum, will be 22 Celsius degree. And the lowest temperature will be my minimum is 12. Now here also have a condition which occurs at 3 a.m. So this tells me there is a point x comma y, so 3 comma 12, that will be a point. When there is a point for a function later on, we can plug it in, x to x, y to y, and we will do the housekeeping and get the answer, okay? So knowing the maximum and the minimum, we know the amplitude, which will be phi, and yes, we know the principal axis, which will be my d value equal to 17. Good. Now, when we talk about this condition about the background story, you notice they're talking about the hour since midnight. So we're talking about a period of 24 hours. So that tells me the B controls the period, but not the period. So B is equal to, now some of you will say that, how do you know it's 2 pi, not 360 degree, right? So when we talk about a clock, okay, the clock face will be a circle. So that give me a good idea, will be a 360 degree. So this is how we get 360 degree, because we're talking about a day. So a day will be 24 hours. So divide by 24 period. That equal to B value is 15. Check. Now, what you see is what you got. This is so true. So given the style of my sinusoidal function, I know that t is equal to, figure out the a is 5, lock it in. Sine of b is 15, parenthesis t minus c. I don't know the c yet, but close the parenthesis. I do know my d is my 17, my principal axis, okay? So now it back to function. What do we mention about function? When there is a point, I can plug it in and solve that. And that's what I did here. I used the point given to us, 3 comma 12, x to x, y to y. Now this moment, the x is my t value and y is my capital T. So that give me 12 is equal to 5 sine of 15 times parenthesis, 3 minus c, close parenthesis, plus 17. Now housekeeping, both side minus 17, I got negative 5 equal to 5 side of that, right? Now housekeeping, both sides can divide by 5, so that gives me negative 1. It's equal to sine of 15 times 3 minus c. So that's good. Now we still need to figure out the c. Therefore, this gives us the inspiration, unit circle. So on the unit circle, we mentioned about location, location, location. Always recall a unit circle, x comma y from algebra still remain the same. First come, first serve, okay? But my x is my cosine value and my y is my sine value. So now where do you see my sine value will equal to negative 1? So on the unit circle, you know it's right on that spot. So this is give me, I have an idea. If I start from 0, I go clockwise. Now remember, if we go clockwise, that will be a negative angle. So that would be negative 90 degree, sine of negative 90 degree. That will give me a trig value exactly equal to negative 1. So this is the awesome information about using the unit circle, okay? Now, my goal is to figure out what c value. Knowing the trig value from the unit circle, we can continue do the algebra. Now, we say My original function knows that -1 is equal to the sine of this ugly guy, right? But I do know that my trip value, in order to have a sine angle equal to -1, that is at the -90-degree location. So that tells me this is happen at -90-degree location. I will get the trip value equal to -1 if I take the sine of -90, okay? And what do we know about this part here? This 15 times parentheses 3 minus c, technically it's my angle, okay? So this angle should equal to what? -90 degree. So now I have this relationship right here. So housekeeping, both sides divide by 15. I got -6 equal to 3 minus c. And both sides, I'm going to do what? Plus 6 on both sides and move the c to the left side. So c is equal to 9. Check. So this tells me my ABCD is complete and my function is complete. Capital T is equal to 5 sine of 15 times t minus 9, close parenthesis, and plus 17. Ooh la la, good. Okay, now when we go back to part B asks us, hence, by using the technology, find for how many hours the daily temperature was above 20 degrees Celsius, right? Now, here the keyword, how many hours I will see above the 20 degree. Now, remember what we say, when there is a picture, the answer is in the picture. So my inspiration, it is, I shall grab the function. And once I grab the function, I'm going to look for the intersection, and that will be my solution. Now, when you take a look at my answers, I do want to show you on the fancy calculator. So let's go back to the fancy calculator. Now, because we mentioned about a clock face is 360 degree, right? So make sure my mode is on degree. Now, when I go back to my y equal to, I'm going to enter my left side, 20. Right side is this trig function, sinusoidal function. Now, how about my window? I fix my window. -10 to 30, count by 10 for my x, and y is from -50 to +50, and I also count by 10. So now let's see if the picture is good for me. Well, you do know that it's a sinusoidal function, it's a curve. And the intersection, now remember we're talking about time, so the time should start from 0, midnight, right? So I'm going to look for the right side here. Where do you see above 20? So above the blue line will be only this part here. So this is the green part I highlight here. So from where to where? So I'm going to look for my 2 intersection point, and this is what tells me I got to go to second trace. I'm going to number 5 because I'm looking for the intersection. And yes, I want this location. So I'm going to hit first curve right there. Good. Enter. Second curve. Yes, about there. Enter. Do you want me to guess the intersection point for you? Please, please do. So I got 11.46. Check. Now we're going to get another point for here. So repeat. Second trace. Number 5, intersection. Now this time I need to move the fraction line to this right side intersection. So keep moving. Okay, about here is good with my awesome eagle eye. First curve, good, enter. Second curve, good, enter. Do you want me to guess? Please do. So when I hit enter, I got 18.54. Okay, so from here, we got 11.46, and here we got 18.54. Now remember, the question asks us for how many hours from here to here. So that will be a difference. I need to subtract from each other. So I got 7.08 hours because this question is based on the time in hours. Okay. Now if you say that, oh, I know that by my awesome smartwatch, it will be 7 hours and 5 minutes. You are correct. All right, and that's all for today. Thank you. Have a good day.